Hello, so today I'm going to explain how to make a Leyden jar, what a Leyden jar is, and how essentially is it working. So first, a Leyden jar was originally used to store electric charge after transferring some charge into it. There's multiple variations on Leyden jars based on like the types of materials that people may use, but in my video, I'm going to focus on the version of a Leyden jar made with a plastic water bottle, nail, tinfoil, and salt water. So first, to make the Leyden jar, as I said before, you're going to need some materials. So you're going to need a nail, you're going to need aluminum foil, a plastic water bottle, with preferably flat sides. Mine doesn't have flat sides, but yours, if you're able to, I say flat sides, salt water, a PVC pipe, and a cotton cloth. So you need the nail in order to transfer electrons or the charge into the capacitor, which is this Leyden jar. And you also need aluminum foil, which will serve as one of the conducting plates. The plastic water bottle will be an insulating material, and it just is the body of the Leyden jar. The salt water will be the conducting material inside the Leyden jar since salt is conductive. The PVC pipe will be used to charge and transfer the capacitor, and the cotton cloth will be used to charge the PVC pipe, which is used to charge the capacitor. So first, to build your capacitor, you're going to build your Leyden jar, you're going to open your plastic water bottle. And if your water already has water, if your water bottle has water in it, just add some salt water to it and give it a nice shake. Otherwise, if it doesn't, then just fill up your bottle with some salt water. The amount of salt isn't too important. I use roughly around 1 teaspoon, but just add a good amount. Next, you're going to take your nail and you're going to put it through the lid of your plastic water bottle. Try to get it in there so that the nail is also touching the water itself, the salt water. Next, you're going to get your tinfoil and you're going to wrap it around your water bottle. When doing this step, try to make it so that the tinfoil is is touching the water bottle very tightly and very securely, and tape it off or glue the tinfoil on to make sure it's secure and doesn't move. Try not to overlap your tinfoil either. In the video, I know I show overlap, but after I did clean it up a little bit. And that's all. That's your capacitor. It's your aluminum foil, salt water, plastic water bottle, and nail. So now the question is, how do we charge the Leyden jar? So first we need a plastic tube. I have a plastic PVC pipe, and we need a clean paper towel or cotton cloth. I have this orange cotton cloth. So you're going to take the cloth and you're going to rub it against the tube many times, just like I show in the video. And you want to be able to hear or feel the static electricity made by this action. And then, using a sliding or gliding motion, touch the nail sticking out of the Leyden jar to charge it. The electrons from the tube will transfer to the nail in the jar. This action is called triboelectric. Repeat this process multiple times. I did 5 times. I would say at least 5 times so enough charge is stored into the capacitor so when discharging, you're able to feel the shock. So now, hopefully, you've successfully charged your Leyden jar. So, to check if your Leyden jar is actually charged, like I said before, touch your finger to the tip of the nail. You should feel shock. My shock wasn't as strong, but it like shocked me itself. But yes, you should be able to feel a shock. So, by discharging the Leyden jar, essentially what you're doing is transferring the electrons, the excess electrons, out of the capacitor since you are grounded, and the electrons will move to the ground. So, going further into the physics, what is the physics behind the Leyden jar and what makes it a capacitor? A capacitor is essentially a device that stores electrical charge with the use of conducting plates. And so, in the same way, this Leyden jar consists of the steel foil and the salt water, which serve as the conducting materials for this capacitor in specific. So, what truly does make this a capacitor, let's look at the physics behind the charging and uncharging process, since that will help us determine and find out more. So, the charging and discharging process both consist of the transfer of electrons, which is how the charge is stored in the Leyden jar. So, first, when we charge up the PVC pipe using a cloth, we rub the PVC pipe, creating an excess charge, an excess negative charge on the PVC pipe. Essentially, what happened was that the friction from this action created static, which allowed the PVC pipe to become negatively charged. With this negatively charged PVC pipe, we then charged the capacitor or the Leyden jar itself. What we did was, through the action of triboelectric, we transferred electrons from the PVC pipe to the nail. Since the Leyden jar was essentially before neutral, it had no excess charge, but the PVC pipe did. When we touch the PVC pipe to the Leyden jar, the electrons want to move and they want to spread out because they want to be evenly distributed. So the electrons went into the Leyden jar.
So how does this transfer of electrons work? Why do these electrons even transfer into the nail into the Leyden jar? So first we have to remember that we've grounded the Leyden jar. We're holding the outside tinfoil apart, or we're using a wire to ground the Leyden jar. So essentially, when we bring the PVC pipe, which has an excess negative charge, to the nail, and we transfer the electrons to the the electrons from the nail will transfer into the salt water, which is the inside conductor. This will make the salt water have an excess negative charge. Those electrons won't move anywhere because we have the insulating plastic material around the salt water. So now the salt water is negatively charged. If the salt water is negatively charged, the outside tinfoil wants to oppose that charge. It wants to become positive since the electrons in the tinfoil want to be as far away from the electrons in the salt water, since like charges repel. So what happens is those electrons on the outside tinfoil will leave through us, since we are the ground, or through the wire that we're using. So it'll leave and go to the ground, which if electrons leave the tinfoil will have an excess positive charge. So this is how these conductor plates become charged. The tinfoil will become positively charged and the salt water would become negatively charged. And this allows the Leyden jar to hold this charge, which can be used later or it can be discharged.
After those charges are stored in the capacitor, now the capacitor is charged. And for the discharging process, we have to get the excess electrons out of the capacitor. And so by doing so, we are the ground. That's what I did in the video. I was the ground and I touched the nail. By touching the nail, all the excess electrons wanted to leave because, again, they want to be evenly distributed and they want to leave the capacitor. So when I touched the nail, the electrons went through me and to the ground, which made the capacitor again neutral. And that was the spark I felt. So overall, that charging and discharging process explains why a Leyden jar is considered a capacitor. It's able to hold the charge in its conducting plates, and later on, it's able to discharge that charge. So thank you for watching my video on how to make a Leyden jar, what makes it a capacitor, and the physics behind it. Um, that's all. Thank you. Goodbye.